Okay, we are going over right now, what, 10 to 13, right? So 10 to 13. Here's the picture that goes with numbers 10 through 13. But let's explain a little bit. It says point H is the in-center. So the point H is around here somewhere. It's the in-center. Talked a lot about this yesterday. I hope that you go over this tonight, or hopefully you went over it last night. Okay, maybe that might be a little too much to ask, but it'd be nice if you went over it last night when we talked about this. So what's the in-center? How do we find the in-center? What do we do to find the in-center? That's right, you find the angle bisector. So I'm bisecting this angle right here. And I just want to explain to you how they draw this picture. I don't really like a couple of the things that they've done here as far as drawing this picture, but let me explain to you what they did, because it took me a little bit to figure it out. Again, I want to bisect this angle right here, so I'm looking about right there. Again, I'm not looking to where I'm hitting the other side, am I? I'm looking right here. So my eyes, and I know you can't see exactly what I'm looking at, but I'm looking right here to bisect this angle. That's what I'm looking for. Now, if I bisect the third angle, where should it go? It should meet right in there, right? Would you agree? All right. Now, that doesn't look exactly like the thing in the book, does it? Well, what they did was this. Did you notice what they did? They just took this bisector and just took it to that point, to that in-center. Do you see that? And then they went from here, instead of going all the way across, they just took it to that point where they intersect. Same thing here. They just took it to that point of intersection. All right, so that's what they did. Now, there was something special about that point. That's the in-center right there. Remember from yesterday what's special about that point? Yeah, it's equidistant to the sides of the triangle. So what does that mean? It means it's got to be perpendicular to that side. So that distance, that looks perpendicular. Now, apparently I didn't judge this very well, but I know it doesn't look like it. It absolutely doesn't look like it, but technically that's supposed to be the same distance. And why would it be off that much? What would cause it to be off that much? Because what did I do? Yeah, because maybe I didn't bisect it exactly. Like this one right here, it doesn't look, looks like that's a little smaller than that, doesn't it? I could have been a little more careful bisecting the angles. If I would have truly bisected the angle, see, this probably would have come down in here. That would have been a little longer, a little shorter. It would have looked a little bit better. Would you agree? So it's just human error, right? My error, Mr. Hamrick's error, that these three blue lines aren't exactly the same, right? But if I did it correctly, if I truly bisected all three of these angles, they would meet at a point that was equidistant from all three sides. All right, so, but I didn't draw it exactly right. But we can still go with this. So this is what we have right here. Notice, from this point to this point is not a straight line, is it? It kind of looks like it if you look in the book. If you look kind of quick, doesn't it look like from here to here is just straight? Maybe a little bit, kind of does. And it looks like from here to down here kind of looks like a straight line. But it doesn't necessarily, it's not necessarily true. So that's one thing. By looking at the picture, you may have made an assumption. This is C, isn't it? That's right, so don't assume. We know what happens. We don't want to say that. Alright, let's fill in the rest of these things. Now again, here's another thing that, we'll just do this in a different color here. Let's go, I don't know, let's go this paint color. Here's another thing that might throw you off a little bit. Now most of these are pretty obvious, like they put the 24 here. What is the length of 24? What's 24? AF is 24, isn't it? Right, and 25, they put a 25 right here, and this is a H in the middle, right? So that in-center is point H. So AH is 25. That's pretty obvious. The 30 degrees right here, that's this angle. Okay, that's what they're telling you with that 30 degrees. The 11. The 11 is the one that it's kind of hard to tell which one it is, isn't it? Because they put a big old 11 like right here. How do you know that it's not this one or if it's this one? I don't know. To tell you the truth, they should have put it a little closer, maybe a little smaller. I'm not really sure. But this is the 11. From B to H, that's supposed to be 11. Everybody understand that? And that could be confusing by looking at that picture. Wouldn't you agree? I mean, it looks like it could have been HG according to that picture. But it's actually HB. So they could have made that much more clear than what they did. And this angle right here is 28 degrees. And I think that's everything that they told us, isn't it? Yeah. And so they ask you to find some things. So let's, number 10, they ask you to find DH. Line segment DH. Well, let's take a look. Here's line segment DH, which is that blue one. Now, what's true about this blue one? Well, it's equal to this blue one. It's equal to this blue one, isn't it? All right, so that could be helpful. So remember that. Let's see. What in the world do we know here? Well, we don't know this, do we? Is there anything else I might know? Well, I know this is 11, right? Oh, I see it. I'm not going to really find this blue one right here. What I'm going to do is I'm going to find this blue one, HF. Now, if I find this one right here, HF, isn't the exact same thing as DH? Would you agree? Because all the blue ones are equal to each other. But why in the world did I decide to go up here? Well, because this one right here, I don't have enough information. The only thing I know on this blue line right here, I know that's 11, right? But I don't know this length, and I don't know this length, obviously. That's what I'm trying to find. What about this blue one on this triangle? Well, I know this is 25. Do I know anything else? I don't know. Maybe I do. Maybe I don't. But let's look at this triangle. Look at AFH. Everybody see this triangle up here? Everybody watching? AFH, this triangle right here. I actually know two sides of that triangle, don't I? And it's not just any old triangle. What kind of a triangle is it? It's a right triangle, isn't it? That's 90 degrees. That's 90 degrees. So look what we have. We have a right triangle with two sides. We've learned this before. In fact, you learned it in Algebra 1. I'm sitting in Mr. Smith has his Algebra 1 class during my planning period, so I'm in here. Usually I have my headphones on, but they're doing Pythagorean Theorem right now, and so that's Algebra 1. So I know you guys had Pythagorean Theorem, and that's what we have right here. Look, I've got a right triangle, and you may not have thought about using Pythagorean Theorem, but we've done that a couple times in here. We haven't done it a ton yet in here, but we have done it a couple times using Pythagorean Theorem, so it's not beyond your scope of possibility. So look what I have. I've got a 24. Don't know this, do I? That's what I'm trying to find. And I got this to be 25. Tell you what, let me just redraw it so it looks a little bit better. All right. So what do I have? I've got 24. Which one is the 24? That one right there. Which one is the 25? It's the hypotenuse. It's opposite the right angle. And what am I trying to find? That little short one right there. Can you use Pythagorean Theorem to do this? Watch. It's x squared plus 24 squared equals 25 squared. We can use a calculator to do this. How do I get x by itself? Well, I got to subtract a 24 squared from both sides. So I subtract a 24 squared to get rid of it, and then I got to get x by itself, so I take the square root. All right, I'm just going through this quick because I can't sit here and take the whole class just to teach a Pythagorean Theorem, okay? You should have known it already. We have gone over it a little bit this year, all right, so it shouldn't be brand new to you. So x squared is equal to 25 squared minus 24 squared. So let's put it in here. So 25 squared minus 24 squared right there, and that's equal to 49. I don't even need a calculator now. So x squared is 49. How do I get x by itself? Take the square root, right? We've talked about this year, haven't we? So what's the square root of 49? It's 7. So what is this blue one? I'll write it in blue since it's a blue line. What's this blue one right here then? It's 7. What's this blue one right here? It's 7. What's this blue one? It's 7, right? They're all 7. So what did they ask for? They asked for DH. So what's DH? It's 7. All right? So that was a little tricky. All right? You probably didn't think about having to use the Pythagorean Theorem. But when you have right triangles, okay, if they give you right triangles and you know a couple sides of a right triangle, that should be the first thing you think of. All right? Does that make any sense? Okay. I'm not sure if I give you a Pythagorean Theorem one on the test or not. I mean, it possibly could. I mean, if I do it in class, it's always fair game, but I'm not really sure if I do that or not. So let's do number 11. Number 11 is BD. BD equals whatever. All right, so let's find BD. Well, look at this. I've got another triangle down here, don't I? And it's not just any old triangle. It's a what? It's a right triangle. Now look at this. I know this side is 11. I know this side is 7. Guess what I'm going to do to find DB or BD? Do Pythagorean Theorem again, right? It's not a new lesson. Okay, so I do Pythagorean Theorem again. Let's set it up. We'll call this y. Is that right? So I've got 7 squared plus y squared, or y squared plus 7 squared equals 11 squared. So let's do that. Y squared plus 7 squared equals 11 squared. Your hypotenuse always is the one that's by itself, okay? It's the two legs. It's the 7 and the y that you square and add up. Okay, it's always the hypotenuse, the one opposite the right angle, that's always sitting there by itself. And that's what we did up here too, isn't it? All right, so now let's do this. So let's subtract 7 squared from both sides, and let's put this into our calculator. Scooch this over. All right, so let's put it in there. So it's 11 squared minus 7 squared. Okay, and that equals 72. So y squared, it's supposed to be a squared, y squared equals 72. Problem is, this doesn't come out nice and even like the square root of 49. So, but let's just stick it in the calculator anyway. Let's take the square root of it. That's what we're going to do. So in this calculator, I go square root of 72. And then that equals about 8.48. So we'll round it to what? 8.5, right? And that's what I read off to you too, isn't it? 8.5. That's how they got 8.5. It's not exactly 8.5. It's approximately. But if you wanted to do this, if you wrote the square root of 72 as your answer, I would have been perfectly fine with that. To tell you the truth, me personally, I'd probably prefer that you wrote it the square root of 72. But you can put it into a calculator, get 8.5, and that's what I read off to you. And that's what the book wrote down as their answer. So we've done 2 Pythagorean theorems. We've hardly done Pythagorean theorem all chapter, have we? And then they throw 2 out, at you. So, sorry, I didn't write the problems, but I said it could be. I said if I do it in class, if I do it for you in class, it's always fair game for a test. And I don't know exactly if I put one where you have to know Pythagorean theorem or not, but we've done it. You should know how to do it now, and you should be good to go. All right, let's take a look at number 12. Angle HAC. Angle HAC. Well, let's find where HAC is. Let's change colors a little bit so it stands out. Let's go green. HAC. Where's H? It's right here, and then A, and then C. So HAC. I'm looking for that angle right there. Everybody see that angle? So how in the world are we going to find that one? Well, we do know something about this angle. This angle right here and this angle right here. Tell me something about these 2 angles. Come on, how did we get the incenter? How did we get the incenter to begin with? We bisected the angles, didn't we? Okay, so this angle and this angle have to be equal to each other because that's how we got the incenter. We bisected the angle. So, all right, that might help a little bit, that these 2 angles are exactly the same. Well, let's go down here. What are other angles that I know some measurements of? I know this is 30 degrees, right? So if this is 30, tell me something about this angle right here. That's got to be 30 degrees, right? Because it's being bisected. What else would you do with this? If this is 30 and this is 30, and this one are the same, what else? The 28, right. This is 28, and guess what this one is right here? That's also 28. Does that give you any idea how to solve for this? Because watch, what's this whole big angle B right here? How many degrees? 60 degrees, isn't it? What's this whole big angle C right here? Well, you add them up, and that's 56 degrees. So look, can we find big old angle A? Yeah, because look, I got 60 and 56. What do I do with those numbers? Add them up and then take them away from 180. So let's add them up. What do I get? That's 116, I think, isn't it? Yep, so what's 180 minus 116? Well, let's do that. That's a 7, that's a 10, that's a 4, a 6, so it's 64. So this whole big angle is 64 degrees. Is that what they're asking for, though? No, they're asking for just this little angle right here. They're only asking for this angle right here. So if both of these add up to be 64, and they're both exactly the same, say it, then it's 32, exactly. So that angle right there has got to be 32 degrees. That's definitely something you should be able to do. Pythagorean theorem was a little stretch because we haven't talked about Pythagorean theorem very often, and it's just something that you might have not thought of. But this right here with the angles, that's definitely something that we've talked about. But you have to know that if this is the incenter, you have to know that you bisected those angles. If you didn't know that, then you wouldn't be really sure on that these 2 angles were equal to each other. and that these two angles and these two angles were equal to each other. All right, so you got to know vocabulary, you got to know what the incenter is and all that good stuff. All right, it's been recorded. All right, so if I went a little fast, go back, slow it down a little bit, maybe draw the triangle without all those lines in it. You know, just draw the angle bisectors of them, and then you know, it might make a little more sense to you, but you're going to have to try this on your own. All right? Let's do one more. Let's do number 13. Kind of going crazy with my colors over here, but that's okay. Angle DHG. DHG. Fellas, you getting all this? What if I had this on a test tomorrow? Josh, come on now. Get your head up, please. It's just rude to have your head down, okay? You know, you can have a blank stare on your face. You can just look up at the ceiling if you want to, but just keep your head up, all right, and just show a little respect. So DHG, where is D? Right here. D is right here. There's H and there's G. So I'm trying to find this angle right there. So how in the world do I find that? Well, let's think about this. I've got it. Let's just look at this triangle right here. Everybody see this one? Right here. Okay, so let's just look at that triangle. Look, I got a 90, right? And I got a 30. So 90 and 30 is 120, right? Take 120 away from 180 and I get what? 60. So this angle, this little angle right here where the dot is, that's 60 degrees. What do you think this angle right here is? Let's make sure it's 60, okay? Because look, that's a right angle. So there's 30, there's 90. Again, that's 120. So this little angle right there, I'll just put a dot since it's kind of cramped in there. So that's 60 as well. But I want to find the whole big angle, angle DHG. I want to find this whole entire thing right here. So if this is 60 and this is 60, what's that whole angle? It's 120. Just add the two together. All right? That's not so bad, is it? But you gotta see stuff. You gotta look around, and you have to see, okay, if I'm trying to find this big angle right here, what other angles do I know, and how are they going to be useful to me? That's what I ask myself when I see something like this. I'm like, okay, well, I know this is 30. I know this is 90. Oh, wait a minute. I got a triangle. I got a 30. I got a 90. Take that away from 180. That's got to be 60. Do the same exact thing to this triangle. 60 and 60 is 120. So this is 120 degrees. The angles were a little easier, weren't they? Yep. There you go. That was, that was pretty tough. I don't think the angles were that hard, but the Pythagorean Theorem, I think it was only difficult just because we don't do Pythagorean Theorem a lot in here. But we have done it, all right? We have done it. So it's something that I very well could ask on a test or something, all right? Let's skip around. Let's do... what about 2, 3, and 4? Centroid. All right, so we did incenter. That's the angle bisector. Let's do centroid. Let me pause this while I draw the picture. Okay, so we're going to find the centroid. We find the centroid by doing what, class? The median, right? So everybody knows that, right? Okay, good. So where am I going? I'm going to the where? To the midpoint here, right? And go from here to the midpoint of this side. I'm looking at the midpoint of this side. That looks around in there somewhere, pretty close. And then this is going to go right here. All right, hits the median, or hits the midpoint of the opposite side. All right, so that point right there is our centroid. Let's put some letters in here that they use for this problem. And that's F, J right here, and D right here, and G. All right, let's put some numbers in. Let's change colors a little bit. This is 9 right there. This bit is 12. That's all the stuff they tell you, right? And what do they ask for? So this is number 2. This is 2, 3, and 4. So they ask you to find KH. Number 3, they ask you to find CD. And then number 4, they ask you to find FG. All right. Now, what do we know about the centroid? Remember, what was special about that point right there? That's that one where the longer side is twice as big as the shorter side, okay? Or the whole thing, or the long side is 2/3 of the whole thing, the short side is 1/3, and all that kind of stuff, okay? That's the centroid. Again, that's something you have to know. There's no excuse not to know this, because we did a whole review on it yesterday. So let's see what we have. KH. Let's find K and H. I didn't put a K in here. Where's the K? It's right at the centroid, isn't it? So K is right there. That's that yellow dot. So KH, that's this bit right here. They got to tell us something else. Oh, I left something out. They told us that DK was, what, 16? Okay. So they told us this as well. They didn't, for some reason, they didn't write it on the picture. Nope. But they just wrote it out like this, and almost forgot to put that in there. So DK, let's put that in there. There's DK, which is 16. And they asked for KH. Oh, wow, that's easy now, right? Now that you know this is 16, KH is a piece of cake. 16, is that the longer side or the shorter side of this? It's a longer one. So what's KH going to be if this longer one's 16? It's going to be 8. It's going to be half of it, right? The shorter one is half of the longer one, right? We got to remember that, don't we? So if this is 16, this has to be 8, and that's what this is right there. It's as easy as that. Just 16 divided by 2. Let's see what else we can do. CD. CD is from here all the way to here. Now remember, how did we find, what is this point G right here? It's the midpoint, because to find the median, right, this and this are equal to each other. So if this is 9, guess what CG is equal to? 9. So if CG is 9 and GD is 9, the whole thing from C to D has got to be what? 18. See how easy that is? All right, you just got to know stuff. You got to know that it hits the midpoint. If you didn't know that, then you wouldn't know to add those two together, right? FG. Where's F? F is here, and G is all the way across to here. Okay, so this is what we're finding. We want to find that whole entire length. All right, that's not that big of a deal because they give us which one? Do they give us the shorter one or the longer one? The longer one. From the vertex to that point, okay, to the centroid, that's the longer one. So if this is 12, what's the shorter one going to be? But is that my answer? Is it 6? No, because they ask from F all the way to G. So 12 and 6 is 18. It's the same answer, right? 18 and 18, but they're two completely different segments, aren't they? Everybody see that? All right, so make sure you know how to get to that stuff. I mean, look, doing that, the shorter one, longer one, that shouldn't be too hard now, should it? At first, it was pretty crazy when you first saw that stuff. And you thought, 2/3? What? 2/3? How am I going to take 2/3 of something or double it or half? You know, that's all it basically ends up being. Is like if you know the longer one, you take half of it, you get the shorter one. If you know the shorter one, you double it and you get the longer one. If you know the whole thing, what if, now they didn't do this in this problem, but what if they told you, I'm going to make one up here, okay? Let's say they told you that this whole thing, CJ, was, I don't know, 24. You divide it by 3 to get which one? Yeah, shorter one. And which one is the shorter one? KJ, right. So what's 24 divided by 3?
8.
That would be 8. So the shorter one would be 8. What is CK then? It's 16 because I just doubled the 8. All right? That's about the hardest as it gets if they give you the whole thing. To me, I think that's the hardest one. If they give you the whole thing, you just divide it by 3 because remember, this is 1/3 of the whole entire thing. Divide it by 3 and then you double it. And that's how you do it. It's pretty good, isn't it? All right. What else do we have? Anything else bugged you a little bit? When do we get out of here? It's Wednesday. I never remember Wednesday. 20? Okay. Let's do this. Number 24 and 25. We'll just do one of them. We'll do 24. It says they give you one length is 10 feet and the other length is 16 feet. So those are two lengths of a triangle. What's the range of possibilities that the other triangle can be? So how do we do that? Subtract and then do what? Then add. That's all you got to do. It's really easy. If they give you two sides, how do I find the range that the third side has to be? I subtract them. 16 minus 10 is 6. Then I add them. 10 plus 16 is 26. How do I write my answer though? Do I just write it like this? Put X in the middle and then put a less than and a less than. Everybody see it? This means that X is anywhere between 6 and 26. That's how I want you to write your answer. Talked a lot about that yesterday, wrote it on the board, and I said, this is how I want you to write your answer. I told you today when I was reading off the answers, okay, that I wanted you to write this. This is the third time now, at least the third time now, that I've told you to write your answer like this. And that's what I'm looking for. I'm looking to see if your answer's like this. If you do this, if you put 6 and 26, guess what I'm going to do? Because I've told you many, many times, I want you to write your answer like this. It doesn't mean that the answer is actually wrong if you put 6 and 26. I understand what you're saying. I get it. But this is about following instructions and writing it a certain way. Okay, so this is how I want you to write it. So please don't make this wrong when you did the math correctly just because you didn't write the answer correctly. Okay, do it like this. Make sure you do it like that. All right. Okay. I think that pretty much covers it all. If there's some, I'll tell you what I'm going to do. In the 5th period geometry class, I'm going to try to do some of the problems that I didn't do in here. All right, and then if you want to see some of the ones that we didn't cover in here, go to the 5th period geometry on YouTube. Right, it's easy to find. Go to the playlist. Go to 5 where it says 5 geometry. Go to 5th period, and then you'll see some of the problems that we didn't cover today. So between the 2 classes, we'll have covered all the questions on this. Okay. You're going to hang on to that. You're going to turn it in tomorrow when you take the test. So don't leave it in your locker. Don't leave it in your book. Don't leave it at home. Bring it tomorrow, and I'm going to collect it tomorrow before you take the test. Remember, the test is tomorrow. Please study. Be ready for it.